All right, I'm back in play. All right.
Yeah, so that's gonna actually be kind of cool when you go to do your code change publication because you'll have most of it already all written.
Yeah, what they did here, you're going to see. They've made a few little changes in this cycle. I mean, there wasn't a lot that was done to Article 250, but one of the new ones that you're going to see is a new Article 270. Okay, and what that is going to be is where you get over systems when you're grounding over 1,000 volts. Okay.
Okay.
And that's what they did here in 250.1. They're basically explaining here that there was really no change except for the part where it says for electrical installations not over 1,000 volts AC and then fifteen
Okay.
hundred volts DC. But if you look at the committee statement down there, they're going to tell you that that portion of the scope had to be done to reflect what had happened with the new creation of Article 270. Okay,
Okay.
so now they're telling you that this is limited here in Article 250 to 1,000 volts or less, and they've created a whole new article for it. Now, for this presentation, I'm not going through all of Article 270. When we get ready to
Okay.
do the code change update, we'll go through every bit of that because
Okay.
we already have the illustrations for it. So,
One thing you did miss, James, is dun 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 dun. We got Daniel swimming around, waiting. He's circling in the water.
I showed back up. Okay, now this one is where you're going to get in. You're going to look at 250.36, but this is going to deal with your impedance bonding jumpers, and they made some changes here. All right, and basically what they did, they also took 250.36G and added it up here for the bonding jumpers because this is where you're getting in and you're looking at the sizing of your bonding jumpers that you're going to do it in accordance with 250.36B. Okay, so they made some changes here, and what they also did is they changed the term grounded to grounding electro. So that helps match the language that's in the new definition. So if you remember when we started this the other day, or when we first started this, I was in Article 100 and I talked about the impedance bonding jumpers and all that stuff. Well, this is a
Yep.
reflection of that new definition that's going to be there. Okay, so it's still sort of the same, except for they're now coming in and moving 250.36G into this as 250.36E2 and telling you the size of it. You have to do it in accordance with 250.36B, just like you do the other conductors. Okay,
Okay.
so that was a change that took place there. Then they did another one here in 250.64C. This is where you get into the grounding electroconductor installation and part being continuous. And what they added here, they did a little bit of work up in the top up there, but really the main changes in C2. And what they did here is to explain that you're making splices that and they're made at an accessible locations that you can take and use the splice of wire type grounding electroconductors permitted by listed grounding and bonding equipment, but it has to be at an accessible location.
Yeah, and that's an interesting one. I'm gonna have to run that one on a myth because a lot of people see that continuous and they think that you can't splice it or you can't cut it, and it's just required to be electrically continuous.
Yes, and if you look, they also tell you in the committee statement there that splicing by exothermic welding process, and irreversible compression type connectors is still permitted for accessible or non-accessible. But if you're going to
Gotcha.
take and you're going to use a wire type here, then they're going to tell you here that it's permitted, but it's by listed and grounding and bonding equipment, and it has to be accessible.
Right.
They made a change there. That's a pretty good change. It's explaining what you're allowed to do and not do. Okay,
I
but
like
all
that.
the rest of it's still the same. Okay,
Yeah.
and then this is the last one I'm doing here. This is a big change that took place here. Okay, and what had happened was, and I'm gonna go over and I'm gonna show here the uh, committee statement because it's not much, but I'm gonna go through and explain a couple of things. But the very last sentence there, it says, this first revision will provide additional guidance for installation of metal raceway systems into non-metallic boxes or enclosures, which is now commonly being seen in the field. So all they're
Okay.
doing here is they're coming back here and they're saying that you can come in and you can take and have these non-metallic boxes or enclosures where you install these metallic wiring methods. Now,
Right.
when you do this, if you look at number one, it gets into the bonding here, and it talks about where you're taking and using these non-metallic boxes and closures where you have these metal wiring methods, and it says you have to comply with one of these two methods here. All right. So it says if you're using listed non-metallic boxes or enclosures with integral means to interconnect all metal raceway or cable entries and providing bonding for the metal covers shall not be required to have additional bonding means or equipment bonding jumpers installed. Then it says where you have this set up, and it says that the metallic wiring method shall have bonding means and equipment bonding jumpers installed for each metal raceway or metal armored cable entry to ensure continuity of the metal wiring method and effective ground fault current pass.
Yeah, I have to agree with that.
Yep.
David has a really good comment in here. He says, "What drives me crazy is when people think that the grounding electrode conductor from the service, the first ground rod to the second ground rod, has to be continuous." And that's exactly what I'm talking about too, David. That's probably what my
Yeah.
myth's exactly going to be because a lot of people think that.
Sure. And then, well, you hear it. Now they say, well, what if you come in here and you've got a metallic cover that's installed on a non-metallic closure? It tells you here that it's required here to have equipment bonding jumpers or other bonding means installed from the metal covers to the bonding means provided for all the metal raceways and cable armor. And then there's an exception to it where it says that it's supplied by a single raceway or single metal armor cable shall not be required to have bonding where all the following conditions are met. And then they give you these conditions, and they say there are no other metal raceways or armor type cables entering the box or enclosure. The supply end of the metal raceway or metal armor cable is bonded in accordance with 250-86. There is a wire type equipment grounding conductor sized in accordance with table 251-22 installed in the metal raceway or armored cable or equipment bonding jumper attached to the metal raceway or metal sheet cable that complies with 250.118 connected to the equipment or device to complete the effective. So basically what they're really telling you in all this, you still have to maintain that continuity. That's basically what they're telling you where you have these metal objects. And
yeah, and one thing I was gonna say too is I did have one of my top fans message me and want me to cover that specific thing. I think Mike Holt covered it about the metal covers happen to be bonded and stuff. So don't think I'm blowing you off. I'm gonna dig into it and see what I can come up with. And I also do love guys like David Engelhart coming in with the myth of the week suggestion, and I love it. I love myth suggestions. It means a lot. And like I say, sometimes I'll just be sitting there at work and I'll be like, oh yeah, like I run stuff like you can't put MC cable in a conduit. And he goes, oh, you can't. And I'm like, all right, that's myth of the week, And it's just fun stuff like that every time. And I hope everyone has a good time learning the code and just having fun with us. And we do it for fun. We're constantly getting ripped on for trying to bring new content, trying to learn new things, and I enjoy it. I don't care. You know, they can
Not
rip on
me.
me all they want. Doesn't hurt my feelings.
I can even tell you who it is.
Yeah. Well, they can't handle being wrong all the time. That's all I gotta say.
All right, you ready for tool of the week? Let's see
Do
what
it.
we got here.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, this one is actually gonna be a future myth of the week, and this is like a Milwaukee pipe cutter, battery powered. I don't think I've ever seen this before, and I think it is a relatively new tool. Probably used more for like the plumbers and stuff, but we do use them. I've had times before where I've had to like cut pipes that already has conductors pulled in it, and this is the best way to do it. You can just cut the pipe, pull it out, and then kind of get a file in there, ream it out a little bit, and then get a coupling on there, and then slide it back on without damaging the conductors. That's a big myth that we run into is they say that it's a code violation to use these, just for the fact that it kind of drags that metal in and causes a burr in there, and that's a lot of times why we use them when like the wire's already pulled, so that you're not having to pull through that burr. Like I wouldn't say we could use these on just like a general installation practice, but like I say, I'm really intrigued by this tool. I'm actually thinking I could probably get one of these just for my bag of tricks. If we have a thing, I think it even went up to 2 inch, which that could be really interesting if you have like a 2 inch that's in a tight spot. You could use one of these and just kind of get in there, cut it, pull it out, get the conductors out, and without damaging them. So that's typically what we use these for, but I would like to actually run a myth on this too, because there's a lot of people out there that says it's illegal for electricians to use these, and so I tied in a little myth in there with that one. But
Okay.
kind of a cool tool. This one I think you're really gonna like. This is kind of a good one, and like I say, I think you'll nail it. Like I say, it's out of your books.
Question of the week. Okay, let's see.
Yeah.
Let's see. Oh, that's a 800.133B, but there's some exceptions to this. This is just in the. I mean, the general rule is you don't install them together, but there's some others in there where you can go a 1/4 inch or 2 inch.
Yeah, and that's the insulation values,
Mm-hmm.
but that's not. It's weird because you were right about that code reference. I didn't. Is there exceptions in that code reference in 800.133?
Yeah,
Okay.
I think there's exceptions there if I'm not mistaken. God, I'm going off memory here because I don't really look at communication stuff that often. But I thought that there was exceptions to this, or maybe it. Yeah, I think there's. I think if I remember right, there's another one where you deal with other applications that gets you to the 2 inch, and I think that's like B. And then I think the other ones that you're sort of looking at, you got like A1, 2, and 3, but I think A3, I think is the one that has like 3 exceptions there. But
True.
If I remember right, God, man, I'm going off memory here for this. I think exception two is where you get in there and that you get the 1/4 inch. So I, I, I think it just depends exactly what you're asking. Because if you get in and you actually look at A3, it deals, if I remember right, it literally says like electric light power class 1, and you got your
Right.
non-power fire limit, all that in there. Based there that they the communication cables won't be placed in there with any electric light power or class 1, and then you go down
True.
to your exceptions. So I'm just going off memory here, but I guess it depends on exactly what you're asking there. So my main one would be there. You can't put them in the raceway at all. Would be my answer.
Yeah.
They can't be in the same one. But if I'm applying, I think it's exception 2, if I'm not mistaken, it's 1/4 inch. So and then if it's other types, then it's 2 inch. So it just depends which question you're really asking there.
Right. Well,
So-
it's not my question, it's your dad's.
Oh, is it? Well, what did he put? 1/4 inch?
I don't know. Find out.
Well, what was it?
He put the answer is D, 2 inches.
Okay, so he was doing other types. Yeah, that's what I'm saying. It depends which one you're looking at there. So
Yeah.
it should have been.
You could just admit you were wrong. No, I tried to kind of copy it verbatim, but at the same time I tried to put it to make I did change it a little bit, so it could have been on me.
Okay.
Because I should have put electric light power. It might have been a little bit better that way. But I just tried to add that class 1 in there. But it basically was anything that was class 1 was supposed to be separated by 2 inches in the way the question was worded. So it could have been me. It could, I made one mistake this year so far.
Well, when you get in there, I know which one you're talking about, because it does get in and it does list all of those. It lists electric power, all that stuff. So it sort of just depends what. I'd have to see the question. I don't want to comment on it, because that's why I'm saying I'm going off memory what I remember.
It's in the code publication book, and
I'll
it's
look
in
at
the I think it's question number 7.
If he
So,
messed up, I'll wear his ass out to him. He better.
There you go, see? And, oh, you know what? You know what I really screwed up on? I didn't get horns up for Sabaton, and horns up for King James over there in Big Sky Country, Texas. Everyone's got to get a hook 'em horns.
Yeah.
So, awesome. So, did we want to kill about 15 minutes till we run the quiz?
Yeah, I guess we can.
Do the
well,
wall
we
shame?
got the wall of shame. Let's go ahead and get the wall of shame, and I'll put
All right.
some stuff and show everybody
Do that.
what's going on.
Shame. 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 Shame.
So I told Adam if he wanted to pop in, he'd pop in about it's 8:00 Central Time, his time. So we got about probably like 13 minutes. Oh wow, a fandelier,
Uh-huh.
a fandelier.
I figured you would
Oh.
like that one.
Oh man. Well, do they have it like anchored down by something like? What?
When I saw it, I was like, all right, now that's sort of funny, because I'd never seen anything like that.
Is
And I
that
was-
like plumbing strap, like screwing it to the
That's what it
ceiling?
looked like to me.
That is freaking bizarre.
When I saw it, I was like, oh man, that is freaking weird. I actually saw some other pretty cool ones, but when I saw that, and I was like, that's a definite wall of shame.
Yeah, it is. Well, they um they didn't even need an outlet box. No, I'm just kidding. All they need is they just screw that baby right to the ceiling. You know.
Well, one of the things that uh, I thought was funny about it, one of the guys put in, he goes, that was done exactly the way it was supposed to. He said that is art. I was like, yeah, somebody probably
Yeah.
actually thinks that.
You know what would be funny is to actually meme this and be like, I bet you they didn't even balance the blades.
Yeah.
Because, like, that's the one thing we always argue about. And it's funny because I never saw where, like, balancing the blades really mattered or not. But a lot of guys say that you have to balance the blades. And so a lot of times these fans, they come from the factory with specific, blades. And we've seen before where, like, guys are trying to, like, hurry up. So they'll just take, we'll be doing like some of these multi-family, and they'll take like 10 fans and they'll just take all the blades off and they'll just mix them all up. And like, from what I understand, each fan is designed with the blades that go to each fan, so you don't want to like mix them up because they have like different mill thickness and different tolerances and stuff. So you mix them up, then they'll be all wobbly. But that's probably what happened. They probably just mixed up the blades and then they had to put like a blade correction kit on the ceiling, you know?
Yeah, that looks like a much older fixture. Much older, man. It was funny is you can sit there and look and see where it had pulled out of the wall and they just strapped it back up there.
Yeah.
You can see where it's cracked around it.
That's crazy that they had to have found a stud or something to get that to screw back to.
Yeah. I was looking at it, I was like, man, that is one hell of a thing.
Yeah,
that's freaking hilarious.
that's pretty bad. Yeah, I was originally, like looking at the light kit. Like the light kit's like pretty old because like I haven't seen those light kits in like a long time.
That's what I'm saying. That's a much older ceiling fan right there.
Yeah, those. Donald Trump called on his ceiling fan back from the 90s.
All right, I'm gonna pull up. I went ahead and pulled up the full publication so I can show everybody here real quick since we got some time to kill.
Yeah.
And I think everybody will like this. What you'll notice as I go through this, you'll see right over on the left-hand side the motors isn't linked yet. So that's because I'm putting new covers in and all of that, fixing it up. But the first two parts here are completely done. So I'm just, actually everything's done here. But I've got just a couple little things I'm fixing up cover-wise. So if I was looking like at, I wanted to look at size and transformers and connections, I can come over here. You'll see that we've got new covers on all of this, and you can take a quick look and see. We show you how to size Y connected secondaries. We show you how to do the closed delta connected secondaries. I mean, as you go through this, you're gonna
So are you showing those as like coils? Like go back to that last one. Like that one before, are you showing those as individual coils?
Yeah.
So is that like that's like a three phase Y to like a three phase delta or something?
Yeah, and showing you how you get your voltages between the legs and everything.
Oh, gotcha. Oh, all right, that's cool. That's kind of a cool visual, and it kind of shows people how that doesn't really have to be listed either, because how do you list a slab of iron with copper wrapped around it?
Even like here, when we talk about size and auto transformers, we go in and show you the full inside, like you would see connection wise, and showing you readings and stuff you should get, and how to go in and do those calculations. I'll tell everybody, go look at any other publications. You won't see this. We spent a lot of time, and as you can tell, you can look and see we've drawn all brand new testers and everything, just like they, just for drawing wise, about as close as you're going to get. And I'll show you another thing here. I think everybody find this interesting, but I've yet to see this in any other publication. But say you want to come in here and look at secondary ties. This is a really good one. Matter of fact, we're going to get Dad on here to come in and show and explain all this in these bus ties and everything.
Oh yeah, he still owes me a few.
Yeah, well, I think he's going to be even happier because this is actually where we go in and show you how to do all the calculations and everything and determine what the amperage is. So
nice.
we show you bus tie at 100%. We show you doing one at 133%. Then we come over and show it at 250%, and then we come in and start showing you how all this breaks down. Now, this is pretty cool right here, but the one I like is where we get into the loop systems. Because when you get into the loop systems, this is where you start getting into all the different type of loops you could see. So you can sort of see, we took a lot of time and effort to draw these out. So you have a visual of understanding how these transformer ties are put together and how you create all these different loop systems and everything within it. Then we show you how to go and also do all the calculations for it. So
question, like if you have like these tie breakers, is that because you have a different inrush because of the lengths could be different?
Well, sure it could.
Okay.
That's why you get different percentages, and that's why I want to get Dad on to go through all that.
Nice.
He'll explain why they did what they did when they put all that in. Now, I'm going to show one more thing here I think is pretty cool, and I think everybody will like this. Now, this motor part, I'm going to tell you, it is fantastic. But my favorite part in here is where you get in your troubleshooting motor windings and components. Now, come next Friday, I'll have this up for sale as an individual one, okay? And I can tell you, this book, we have done a major increase and upgrade on everything. This book, as one book, is 700 and something pages now.
Wow.
So it tells you how detailed and the amount of effort and work that we actually put into this. But if I look at these motor windings and components, I want everybody to see this. Let's just say I'm looking here, and you'll see we show you how to come in, troubleshoot. We tell you how to test and find the leads for Delta motors. We go to Universal Motors. Whatever it is you're wanting to look at here, we've got it for you. But let's just say I wanted to look at testing and finding the leads of the Delta. Okay? Now, what you're going to see here is we're going to tell you how to test and find the leads of a Delta motor, and we're going to show you how to test these leads here. And you'll see that we've got all the leads marked and everything, and taking the measurements, what your final readings are, and double check your markings. Okay?
Is that, just out of curiosity, stupid question, is that a 9-point or a 12-point?
This is a 9. And you'll see right here, we're showing you it's a 9 right here. Okay? So
gotcha.
As I'm going through this, you'll see as we come down through here, it'll tell you double check your markings, and we tell you go look at 2316G, and then if you look at final readings, we got B through G, and then if I'm looking at taking measurements, you'll see 16. Okay? So when you come over here, it's one thing you can read about it, but we're showing you here how all of this ties in and what those readings should be. Okay.
Yeah, and I get a lot of questions about how to measure a motor. Is that in there too?
Yeah, we have that in there too. We everything you want, it's in here, and you'll see like this in G. This is your final reading. See how we set all this up and show you the connection of the leads and for what test number 1 to see for your rotation test and all that. We show you test 1, test 2. This is what you would see as far as your connection of your leads together. Okay? So as you go through this, all this stuff you're wanting to find out on how to do motors, your resistance checks, and all of that, it's all right here. Okay,
Oh, nice.
testing coils. I mean, it doesn't matter what you want to do. You can see there was a lot of time and effort put into this, so you know how to do your readings. I'm already getting um, all kinds of uh, calls from apprenticeships and stuff. They were saying, "When's that going to be out?" Because that's something we want to teach our kids. So, uh,
So, question for you: you said that publication is gonna be individually for sale. What was that price for that individual?
I don't know yet. I'll know
Okay.
here this week.
Okay.
But uh, say you wanted to get in and you're looking at that, and let's just say I wanted to look at the different types of starting methods that you have. Because see, when you get into types of motors and motor theory, that's where you get into stuff you will want to know. All right.
Right.
So now if I get in here and I look at my starting methods, I just let's just look at the types first. Okay. Here's all your different types here. We got full voltage, we got reactor, resistor, auto, transformer, solid state, Y delta, and part winding. Okay. All of this is set up to show you just like you would see in a schematic here if you were out on the job. Okay.
Right.
And uh, as you're going through this, we even come in where we want to show you something here. We may be talking about how do you take and do the reduced starting current for a solid state uh, starter? Well, right here, we give you an example, and then you come down here in the illustration and we show you the percentage and everything that's used in order to determine that. And then we tell you to get the full load current that since it's three phase, go look at table 430.250. Okay. And there's different types that are set up here based on what you're doing. We even tell you what the starting torque is. So if I want to
Is
look over here in the next illustration, we tell you we did the calculation and we showed you what the reduced starting current was 1,770 amps. And then we come in and we look at this based on the foot pounds and everything here to help you determine what that starting current is, or starting torque, should I say.
so is that would that be like what they call uh like I'm trying to think of what they would call it, like a soft start?
Could be. I mean, you know, all we're showing at that point, we're not giving
Oh,
you any
dude,
specific one.
looks like the Facebook site is working. We got Mike Kozlov over there. Roll Tide from Chicago.
Oh, cool. I'm glad it
Awesome,
is
Mike.
working. That means I did it right. All right.
Yeah.
And then we come in, we show you where you got your controllers here and everything.
Uh huh.
Um, we show you where you got a speed controller that's put in, and all of these have been drawn exactly in digital, like you would see that you're buying new now. And that's why I tell everybody, go look at any other publications out there. You're not going to see where they're coming in showing you how to do all these starting torques and all this other stuff. Okay, so a lot of work has been put into this. Um, I think everybody would be very, very happy with this publication. Well, it's been one of our best selling publications for years and years and years. But
Nice.
uh, another thing that's interesting is say you're coming over here and you're looking at design letters and code letters. Okay, now this is important because uh, if you come in here, a lot of people uh, don't know how to take and use the code letters to come in and do the sizing. So I'm going to show you something here. Let me go down. Okay, so right here, we're getting in, we're showing you where you set up and you do, like for this piece of machinery here, we're going to show you how to calculate and determine the full load torque and what its foot pounds is. Okay, and basically what you need to know what the RPM is. Well, it's 1725. Then all you have to do is put the horsepower, and then you have a constant they use here, 5252. You add all that up and divide it by that RPM, and that'll tell you what the foot pounds is. Okay, and
Right.
we go through and show you all these different things. Now, I'm going to show you one other thing. I think everybody will find this really, really interesting. All right,
Yeah,
now,
and I just want to add something to that, James. We had a job that we did, and they had me go out there to measure the motor because it was relatively new and it was starting to burn out. They actually already replaced one, and they're like, "Man, this thing's burning out way too quick. What's going on?" And I just went and did the calculation. Well, when I measured it, it said that it was like a 3-year-old motor,
mm-hmm.
and it was only like 6 months old.
All right.
And so then I did the calculation, and come to find out, they undersized the motor. They're supposed to size it at 200 horse, and they sized it at 150.
Yeah.
And so I actually proved the engineer wrong, that he sized the motor wrong, and so then basically they had to eat the cost of all those motors they were replacing, and we ended up having to reorder a 200 horse and wired up right. So that's why that stuff is valuable to have.
Okay, now let's look at this. Now, and this is stuff that I just don't think you're going to find this in other publications. This is from years of Dad, mainly, because, he's been involved in the code making process forever. But if you look at the left-hand side there, it says utilizing code letters to find your locked rotor current. Okay? Now, the table you're going to see there, we're going to tell you go look at table 430.7b. That's where you're going to pick up code letters. Now, the only time you're going to really be worrying about this is if it was a motor that was installed before the 1996 NEC and earlier editions. You're not going to be going over looking at table 430.251b. Okay? Or
Okay.
So this is why it's in the code. If you go over and look at that table and you pick up the horsepower there, it'll tell you that the motor with a code letter B marked on the nameplate for that motor, you go over and pick up the kVA per horsepower, it's going to tell you it's at 3.54. Then you just take the horsepower of the motor and then multiply it by 1,000 so we can get it in VA form, and then you'll divide it by the voltage. Where we have a 208 volt three-phase, so that'll be 360 volts. Divide that in for the 70,800, and it's going to tell you that locked rotor current is 197 amps.
Looks like Team SOS is getting ready to jump in here, so...
Okay, well, let me finish one more thing.
We'll round it off here. Adam wants to jump in while we're finishing off here. We're almost there, Adam.
Almost there. Now, let's just say I want to look at overcurrent protection. Now, I'm just going to pull something up here I just want to show real quick. Now, we even come in here and we show what do you do if you have future additions here. Okay? We come in and list all of this out right here, things that you need to take into consideration. And then we also tie it in to let you know that you can have 2 or more motors that are used simultaneously here. Okay? And you have to calculate them accordingly. And then you have to also take into consideration requiring the highest amperage rating. So what we try to pull out here is you could have a very, very large motor that could actually change a calculation that's in a facility. That could, based on that percentage, would require you to have a larger overcurrent device than if you just calculated it normally. So we go through, we show you all kinds of stuff here. I think everybody will be very happy. You'll see that we even show all the connections here. We're showing you here where you're going into the disconnect, going into the controller, showing you what you would look like, and showing you all the connections and everything that's there. So,
Dude,